The last video we explained exactly how the two-stroke engine works, and in this one we're going to talk about two-stroke scavenging. So I've gone to the website. I'm just going to click on the two-stroke scavenging model now. Hopefully it won't take too long to load. Okay, so we can see here that there's three main types of scavenging mode. That's cross-flow, uniflow, and loop flow. Now we'll start with cross-flow since it's furthest to the left. The cross-flow model here is the same one we used in our two-stroke cycle explained video. You can see here that the air comes in, it gets compressed in this space here when the piston comes down, gets forced out, goes into the space, and then it will be exhausted here as exhaust gas. Now this whole setup is called cross-flow. It's not particularly efficient because you lose a lot of the air going out the exhaust gas path. And it also isn't really favoured for large combustion engines. However, it is incredibly simple in design and it's also very lightweight. So this is favoured for motorbikes, outboard engines, for marine vessels and maybe lawnmowers, leaf blowers, anything like that. It's always going to have a two-stroke engine with this type of scavenging process. If we zoom out here, we could have a look at uniflow. We'll leave that one till last actually. And we'll go to loop flow. And we can see here loop flow, the air comes in, goes around, back down here and through the exhaust port. If we look at the exhaust port and the charge air ports, you can see that the air ports here for the charge air are actually larger than the exhaust ports. This makes sense because you want to get the exhaust gas out quickly, and ideally you want to be drawing in a larger volume of air, and you need to do this quickly, so you'll make the charge air ports larger. Also notice the shape. The shape of these ports actually imparts swirl onto the air as it comes in. So this means that as the air is coming in, it's going to have a swirling motion. The shape of the piston, and this is perhaps not the best piston here to display this, but the shape of the piston itself also has an impact upon where the air is going. The piston crown, that's this here, the top of the piston, it will often have a depression slightly larger than this, and that will impart not so much swirl but direction to the air as it comes through, and will help it to loop up and go back down out of the exhaust port. So you're using the shape of the inlet ports to impart swirl, and also the shape of the piston crown to direct the air. If we go back to the cross-flow scavenging mode, this piston as well may be slightly different to what you would truly see in an engine of this type. In an engine of this type you may actually see a small hump here, and the hump is designed to direct the air upwards as soon as it starts coming in. So the air would come in, it would bounce off this tiny bump on the piston, and it would go up here and back round, and this helps with the scavenging process and makes it more efficient. And last but not least, we have uniflow. Now uniflow is a type of scavenging mode that you're not going to see very often. In fact, to my mind, you only see it on large two-stroke engines, particularly marine vessels, so large container ships, large oil tankers and things like that. You can see the ports at the bottom here, there's a lot of them. They allow a lot of air in, so the air is coming in very quickly and in large volumes. And this air is displacing the exhaust gas here, which is going to be let out through this valve. You can also see two fuel injectors. I'd say normally you'd have three, but you can see two fuel injectors here for injecting fuel. And the whole process is very efficient. You're getting large volumes of air in the base, and you're also getting a lot of exhaust gas out at the top. And because of the way the air is flowing into the cylinder, the temperature gradient across all the parts here is relatively low. So you're not getting some very high hot spots. You're actually getting a good spread of temperature across all the parts. And this is quite important. In addition to that, because of the way the air is flowing in and the way the exhaust gas is taken out, it's very, very efficient. It's not like, for example, on the cross-flow here where the air comes in, but some of the air will also go out the exhaust port. That doesn't happen here. What will happen is the air will come in, and fair enough, some of it may go out the exhaust port here or beyond the exhaust gas valve, but generally you can control it a lot better than you can with a cross-flow engine, so you'll waste a lot less air, and all of this leads to better efficiency or higher efficiency. You'll also notice it's not shown on these models, but it's something worth considering. The piston skirt for Uniflow can be quite short. When I'm talking about a piston skirt, I mean this area here. Actually, sorry, here. This area here, the piston skirt, on a Uniflow engine can be quite small. On the other engines, it has to be slightly longer. Now, why is that? Well, if you look over here, the piston skirt is used for covering up ports. You see here it covers the air inlet. You can see here it's going to cover this area here as well. And as it moves further up, it's going to cover the exhaust port here. But you need a long piston skirt to make sure that the timing is correct. If you make the piston skirt very small, then you're going to be sucking air in too early, or you're going to be closing this air off too late, etc. Whereas on the Uniflow engine, the piston skirt can be quite small, because as soon as it's gone past the scavenge air inlet ports here, there is no more timing. The piston goes up to the top, it's going to compress the air, it's going to go through our usual compression, ignition and power stroke, and then as the piston comes back down again, the exhaust port can open. The scavenge air ports will automatically be opened because the piston's gone past the ports, and the air will rush in. So the timing, although there is some timing involved with Uniflow, it's not to the same degree as with cross-flow or loop flow, where the timing is dependent totally on the piston skirt. Even here, if we go over to loop flow, you can see straight away that the piston skirt is that long. So as the piston comes up, it's going to cover both of these ports. As the piston comes back down, it's going to uncover the exhaust port and then the scavenge air port. But